Hello everyone, welcome back to another lead code problem. So this is a very famous lead code problem, that is two-sum. So what we have to do here is, we are given an array of nums and target value, and you have to return indices of those two elements which make up the target value. So for example, the first test case 1 shows us it has the array of 2, 7, 11 and 15. And the target given here is 9. So what happens here is, we will iterate through all the array and we will find out that 2 plus 7 is making 9. So what we will return? We will return the indices of 2 and 7, that is 0 and 1. Even if we return 0 or 1 or we return 1 or 0, it does not matter because you can return the answer in any order. One thing to clarify here is the assumptions made in the problem. What are the assumptions made? That we have exactly one solution, one unique solution in every case, okay? And another assumption made is that you are not allowed, you may or may not use the element twice. What is the hidden meaning in this? The hidden meaning is there is always two separate. The hidden meaning is there are always two separate unique elements which make up the target. Okay? Now test case 2. If I talk about test case 2, we have 3, 2, 4 and we have target value of 6. Okay? So 6 here, if you iterate, you can see 6 is made by 2 and 4. 2 and 4 make 6. So you return 1, 2. Okay? Or obviously you can return 2, 1. In the test case 3, if we see, we have 3 and 3. Now these are same numbers. Okay? So these are two unique separate numbers. So we can make here, there are always two separate unique elements. So here we can see that there may or may not be always two separate unique numbers. So here you return target. Target is given as 6. So you return 3 plus 3 equal to 6 and you return 0 and 1. Cool. So now coming back, one thing is we can solve this in two methods. Okay. First one, approach 1 will be our brute force solution, and the approach 2 is our optimized solution using hash maps. Great. Now let's come to the solution 1. Approach 1, brute force. So what happens in brute force solution? We are going to iterate 2 times. For I equals to 0, I less than nums dot size, I plus plus. Again we are going to iterate for j equal to 0, j less than nums dot size, j plus plus. So here, why are we using j equal, why can't we use j equal to 0? Why should we use j equal to I plus 1? This is because we know that we are not supposed, you may or may not use the same element twice. So there are two unique numbers given in the array. They may be same or maybe not same, but they will make up the target. So we are ignoring the I value, like we are moving forward in the array. Okay. So if, now we are checking if nums I plus nums j equal to target. Now if we form it, you are returning I, j. This is the simplest brute force solution one can make, and we are returning. If we can't find, we are returning -1, -1, but this will never be the case. Now just checking this up. Okay, sorry, I made a little mistake. Coming here. Yep, so this got accepted, but this is currently in big O of n square. So this was not an optimized solution. It got accepted here because this was an easy problem, but we should always optimize. So coming to approach 2. So this is our approach 1. Okay, coming to approach 2 here. It will be simpler to understand if I write above that. Approach 2 using hash maps. Okay, so what we can simply do, let me tell you. Using hash maps means we are storing all the elements in the map whenever we are iterating through them. But as soon as we see that the number, or maybe the nums I, that the target minus nums I mean is already present in the map, then we break and return. Cool. Now coming to the solution, first we have to make a map. So just make an unordered map. Why I'm not using a map here and why am I using an unordered map? Because map, yeah, it sorts, right? The map sorts and the unordered map does not sort. So if map sorts, it takes an excessive time complexity. So that here we don't need that, right? So that is why I'm using unordered map. So then we are iterating through each. I equals to 0, I less than nums dot size, I plus plus. Now whenever we are iterating, I am storing that particular value in map. But before storing, so what I am doing, I am storing nums I plus plus. I am storing, but before storing, always I had to check if target minus nums I. Now this value, if it is already present in the map, mp.find not equal to mp.end, means if it is already found in the map, return. Now how will we get the indexes? So the simplest way is, instead of storing mp num plus plus, we can store mp that number equals to I, means the index it is storing. Okay, so here you are returning the value of nums I, comma nums I you are returning. Are you returning nums I? No, you are storing the, so you will return the value of index of this nums I, that is I, and you are returning mp of target minus nums of I. It will store the complement, means it will store the target minus nums I ka index. So that is why we are doing like this. So I'm telling you, if we do not find these, that is not the case, but if we do not find any of these elements, we return -1, -1. Let's run this and then I'll just make you understand. Yep, that works. This submit. And that's how we reach the 0 millisecond code. So here in the app, if we see, I'm just trying to explain you. In this case, what will be stored in the map? Map stored. Map will look like somehow so suppose in our first test case we have 2, 7, 11 and 15. 2, 7, 11 and 15. So our map will store something like 2. 2 will store what? 0. 7 will store what? 7 will store what? 1. 11 will store what? 2. And 15 will store what? 3. So this is how our map will store. Okay. So that's it. So these are the two approaches we can solve this problem in. One is brute force and one is using hash maps. Thank you.